Copper asprinate is a dark blue crystalline solid that is typically used for the treatment of rheumatoid arthritis. I am making copper asprinate as an addition to my copper series. However, besides that, I have no real use for it. For this preparation, I use about 2.5 grams of acetylsalicylic acid, which I'll just call ASA for the rest of this video, about half a gram of sodium carbonate, and 1.187 grams of copper sulfate pentahydrate. The ASA and the sodium carbonate were both obtained from previous videos, and the copper sulfate pentahydrate can be found at the hardware store as root killer. To a beaker, the sodium carbonate was dissolved in about 20 milliliters of distilled water. To the solution, the ASA was added and stirred. The following reaction occurs where the ASA is deprotonated, forming the sodium salt of ASA, while also forming carbon dioxide and water as byproducts. Sodium hydroxide cannot be used here, as it will also hydrolyze that acetyl group, making salicylic acid. This will take some time as the reaction is a bit slow, but you'll be able to tell when the reaction is done when no more CO2 is being bubbled off. While the ASA is being deprotonated, a copper sulfate solution is prepared by dissolving the copper sulfate pentahydrate in 10 milliliters of distilled water. Once the copper is fully dissolved, the sodium ASA solution is filtered into the copper solution to remove any unreacted ASA. The following reaction occurs when the sodium ASA is added to copper sulfate. Copper displaces the sodium in the sodium ASA, forming a precipitate, which is our desired copper asprinate, while the byproduct sodium sulfate is left in solution. The main reason I wanted to add copper asprinate to the copper series was this interesting structure. Copper tends to only like to bind to 4 atoms, which is no exception here. However, in this compound, each ASA has 1 oxygen from their carboxylic acid group bound with each of the coppers to give the shown structure. So technically the formula for copper asprinate involves 2 copper atoms and 4 ASA molecules. The solution is then filtered and the salt is allowed to dry overnight, resulting in 1.536 grams, which correlates to percent yield of 76.7%. This yield was decent, but it should be a lot closer to 100%. My only explanation for this is really due to my impatience in not allowing the sodium salt of ASA to fully react with the copper sulfate. Despite this relatively low yield, the deep blue crystals will be a nice addition to my copper collection. I hope this procedure was useful, and thank you for watching.